yeah, that was indeed a cut. You are muted.
I thought I
There
had
you
muted
go.
myself before, and then I was unmuting myself, and apparently I just had my order of operations out of order.
All right. So, as y'all have seen, we are now gonna go for our reverse engineering part of KernelCon's Hack Live, and for that, we're gonna have with us the amazing, the one, Chris Eagle. That was awesome.
That was
Now,
fun.
hi, officially hi.
Yeah, how you doing? Can you hear me okay?
Yeah,
Yeah, we
looking
can.
good, sounding good.
You as well. Nice to see you guys.
Thanks. Yeah, good to see you too, man. I miss you. I haven't seen you for a long time.
No kidding. I hope I get to see you. Are you going to be in Vegas? Are you going to be in DEF CON at least?
We're tentative, yes, right? Eyes on the prize and seeing how the situation plays out. Both Marina and I got 2 of our shots, so we're double vaccinated, and then we're just going to keep an eye on like what's our antibody count and how are the variants doing and how are the vaccines efficacy against the variants, et cetera. So we want to be there, and hopefully we'll get to wrap live with everybody.
Yeah, I am in the same boat. So plan is to be there unless things go south.
Yep. Fingers crossed. Well,
Yes.
we are here right now, and we are super excited that you are with us. And so I've never gotten to take one of your classes. Every time that I applied for one with an employer, they wouldn't approve it. I don't know why, because you are literally the person that wrote the books. And so, anyways, I've never gotten to actually see you in action before, Chris. And so this is super exciting for me.
I hope it's not anticlimactic.
I don't think it's impossible.
Watching these last 2 has me a little nervous.
I think you're gonna crush it. I'm very excited.
That's the fun of it. We experienced that a lot with UHC Live. We keep screaming at the screen. We scream at each other. We get frustrated, and then we celebrate whenever we get something right. Sometimes nothing goes right, but at the walkthrough moment, we have the and that's already worth it.
I've been there, so I'll do my best.
Absolutely.
We are 100% sure you will. I'm just so sorry. We have to run for the intro. And Teddy, you have something to add? I'm sorry.
Nope, I got it. I was just I was gonna say that this particular session for the reverse engineering challenge here is sponsored by Hexrays. And so folks who have been reversing will know that Hexrays are the folks who make IDA Pro. And we wanted to say that IDA Pro has long been a staple in reverse.
Okay. So yep. We're so you're giving the speech that we have here. Okay. Sorry. Go for it.
Is there something different I'm supposed to read?
Nope.
Okay.
You can go for it.
Cool. All right. So this is the Hexrays I don't know, boilerplate. IDA Pro has long been a staple in reverse engineering communities. Hexrays provides state-of-the-art binary analysis tools, the sorts of tools where conference presentations and blog posts are adorned with screen captures from the disassembler, debugger, and decompiler. These tools are constantly under development and releasing new features, such as the new IDA 7.6, which supports Apple Silicon, and Golang. Reversing Golang. Oh. You might be familiar with Igor's tip of the week on the Hexrays blog. We're happy to have Igor available in Discord. What up, Igor? Long time no see as well. Used to see Igor at Recon. So we're happy to have Igor available in the Discord, present to interact with you virtually. In addition to sponsoring this session, Hexrays wants one lucky winner to walk away with an IDA Home license. Pay attention to this session for your chance to win. And also to learn a bunch of really cool stuff from Chris. But you could also win an IDA Home license.
That's amazing. All right. So we are now going for our... Oh, wait a minute. I'm going to first introduce... I'm sorry, y'all. I have like 5 screens around me. So I'm going a little bit crazy, but... Yes, we are now going to have Chris Eagle here with us solving the challenge. And before we go for our live voting reveal, so if you have not voted yet, go vote on the Discord server on what challenge Chris is going to face. I'm going to introduce him a little bit. So Chris Eagle is a software security researcher. He has been a computer engineer slash scientist for over 35 years.
What? You don't look a day over 22. How do you do that?
I mean, yes. It's the live streaming effect, you know.
It's staying inside and reversing all the time. No sun, no, you know.
His research interests include computer and network operations, computer forensics, and reverse/anti-reverse engineering. He was the chief architect of the competition infrastructure for DARPA's Cyber Grand Challenge. That's cool, yeah. Chris has been a speaker at conferences such as Black Hat, KernelCon, DEF CON, and is the author of the IDA Pro book and the Guidra book. So in his spare time, he will be probably playing CTF and RC play. So yes, that's Chris Eagle for y'all. You're satisfied with that. Now we're going for the live voting.
Yeah, I don't think there's a vote, right? I think, Chris, you've already got your binary that you're going to take apart.
I just received the binary. Yep.
Oh, yeah, that's true. No live voting here. Perfect.
Cool.
So we're pretty much ready. That's it.
Okay. So what am I? I'm going to screen share.
Yeah, and so here, here in the application, there's a button there for sharing.
Yep.
Cool.
Amazing. So yeah, we're going right at it. So Chris, you will have, I think, plenty of time, but well, we'll see. You have around an hour and 20, 30 minutes ish to go all the way you want and have your fun and get wild and get frustrated and scream at the screen and, you know, hit your laptop or whatever you want to do. So y'all have fun.
Cool.
Okay, I love that. Let's see. Okay, so let me get out of so we don't see the mirror thing showing.
What? We don't want to reflect infinitely? Come on.
It's a fun effect, yeah. Okay, so here we go. I received the binary, and the binary is called something like, is it Among Them? Right, so, you know, I typically see what is this thing I got. So file tells me, you know, it's a 64-bit ELF dynamically linked, right? For Linux, I then usually run strings looking for something very specific. Strings. So apologize for all my typos. It's not what I wanted. Stress is already getting to me.
No worries. What does the -I flag do?
It does something better when it's in the right place.
Oh. Oh, that makes more sense.
Okay, so it tells me, so all that really tells me is maybe where it was built a little bit. So GCC 10 is pretty new. It looks like it was built on Ubuntu, so maybe an Ubuntu 20 box, right? So if I have to do anything with libraries, if I need to know a libc version, for example, if it comes down to that, I'd like to be, you know, in the vicinity of the right libc. Okay, so I'd start sniffing around maybe an Ubuntu 20 box, hoping that I'm going to get a libc that's pretty close. We'll see if it comes down to that. My tool of choice remains IDA. You know, Ghidra is out there, and I was co-author on a Ghidra book because I had some experience with it. For those that might have missed it, I did post a code from No Starch in the Discord. It's probably scrolled up a bit for you to get a 30% off on a copy of the Ghidra book, special KernelCon deal. Hope to have another edition of the IDA book coming out, hopefully early next year. And looking forward to talking about all the features of IDA that have been incorporated since the last one.
Whoa, that's awesome.
So let's see. So I got that plug in there. All right, KernelCon 2021. We go get our binary. And I'm going to probably minimize. I'll talk about IDA where it's helping me, but hopefully everybody's familiar with all the basics. I do a lot of teaching, and so I usually talk my way through all the basic IDA stuff. I am not monitoring Discord right now, so if there are Discord questions, int80 or Marina, if you want to
Don't
throw those
worry,
at
yeah.
me, that's great.
Y'all in the Discord server, if you want, you heard the man, just at me and I can pass on your message.
So they did me the courtesy of stripping the binary, right? So that means I don't get their symbols, but IDA does a nice job of identifying at least main right here, right? So it's going to drop you off at the entry point. Here's our start routine, right? Which is probably not interesting to us. We'll come back if I think there's some tricks going on with constructors. We'll try to track that down later on. But jump into main. I also, for most CTS, I do something like this and just eyeball it. Like, is this going to be a monster problem, right? Or is this going to be maybe a doable problem? So we're in the 19K, relatively small binary range. So that's a sigh of relief. And it doesn't look like it's Rust or Swift or something just awful that it's going to come in at like 300K and all kinds of stuff. But you never know. So I tend to go straight to disassembly view, although we'll throw it up in the decompiler and see what we get. And walk through it, right? Set vbuff, that's just unbuffered standard out, so things don't get stuck in standard in libc buffers, right? And so you're sitting there waiting to see something, like you're doing a read until and nothing's coming. They're going to alarm me. So for local testing, I always get rid of that. So I'm just going to hop into, let's see. There's lots of different ways people get rid of this. And I should say up front that I'm not a Pwn Tools person. So yeah, maybe some of this is pretty easy in Pwn Tools, but I do my own thing. So alarm 0, right? Go to the hex editor and hexrays. Alarm 0 is going to zero that out. And alarm 0 resets any alarm and basically disables an alarm. So I'll have as long as I want to on the debugging side. So I'm going to apply that patch down to the original binary. And so now when I shove this into a VM to do some local testing, I don't have to deal with alarms.
Quick announcement here. You can use the code KernelCon25 and you get 25% on no starch press until May 14.
Nice. Get those Chris Eagle books.
Yes.
This is supporting No Starch. What a great company. They make great. They publish great books, and just from an author's perspective, they couldn't be better to work with. What are they doing here? So we have a short loop, right? Counting to 10, and we're setting up a buffer with basically the numbers 1 through 10. Looks like star v4. They're incrementing it, getting a random number. They did srand with time. Okay, so that's gets a little painful. So they're getting some reasonable, maybe random numbers out of here. Every time they get a random, they call some function here. And they're going to do that until they get a 0 out of that function. But they're only taking 1 byte of randomness. It looks like they're treating that as a char when it goes in. So another buffer here. Well, let's see. Star v1 is not equal to that. They like this number 33. and that's 10 times. So there's something. 33 is an interesting size here. I don't know if that's going to be a struct, a string, whatever it is. So this is probably maybe we'll just call it a char array for now. I'm addicted to data types and data typing and so on. So if I turn this into an array, IDA suggests it's going to be 320 bytes, right? There's a double down here at the end. The code suggests it's 330 bytes, which would be 10 blocks of 33 bytes each, right? So we'll hold off on turning that into a two-dimensional array for now. But it looks like the first byte of each of those 33 byte blocks is significant. Okay, and they're just checking to see that they haven't seen the current random number before. And once they have, they just say, okay, right? So v1 equals, that's the end of the array. Okay. So if they don't find it, or if they get to the end, they're returning 0. If they find that byte already in their data structure, they return a 1. And am I getting that right? Let's see. Yeah, they reach the end, they return a 0. And so as long as they reach the end, meaning they didn't find it, right? They go ahead and do that loop. What else? I'm going to do a stir copy 30 bytes into their v4 pointer here. First byte of this thing is the number 1 through 10. What are they doing with v6? v6 is their random number, mod 34. So it's I have to start thinking about this. Let's see. So let's look at the stir copy. All right, so they got a variety of strings they're choosing from. And it looks like they're choosing any one of 33 or 34 strings, right? 0 to 34. Each string can be up to 30 bytes. And they're copying it into the current buffer, right? v4 sub 30, random 4 plus 1. So they're getting us a number between 1 and 4. v4 sub 31 equals v6. What was v6? v6 is their random number that was approved here, and then they jump forward to the next thing. So this buffer actually starts 1 byte prior. Okay, and so what we have is some structures that look something like along this line. Right, we have a 1 byte sort of index value or ID value, 30 byte buffer, and then 2 more bytes to give us a 33 byte structure. Right, and that's why. So this structure starts up here, and there's going to be 10 of those, it looks like. And that should do it for that. Let's see if we can't start typing our pointer. We can't really type this pointer because it points 1 byte into the structure, but that's okay. Then they advance by the size of the structure. I apologize if I cough in anybody's ear. I'll try to mute my mic anytime I got to do that. My allergies are getting me. Set locale, not great. I don't know what that is. Hope it doesn't have a huge impact on me, but it might. Oof. Category 6 with a null locale.
Yeah, I see the locale stuff being used in places where there's bytes in the string that may cause trouble for other locales. So like a lot of times I'll see like LC underscore all equals capital C or something like that.
Okay. So this is a query in any case, right? So locale is null, right? So it's only a query, and so the locale is not being modified, right? Because this second, the pointer here is null. So hopefully that's not going to do anything to me. So let's see, they're going to start writing some bytes out to me. Oof. Or writing some strings, right? So puts is going to give me these strings, a lot of different strings. It'll print everything up to a new line, right? These are pretty hideous. So maybe there's some way to decode them, or hang on a second. It occurs to me that these could be emojis. UTF-8 emojis, nice. Do I get to go talk to Igor and like ask how to use IDA even better?
He is in the chat having the time of his life, just laughing.
I bet he is. Let's see. So, you know, IDA, I haven't never learned it because I've never had a need to, but IDA, they've significantly improved their string handling in the most recent versions of IDA, right? And what do I try to turn? No. So if I'm turning these into strings, I don't know if that's
Wait a second. This looks like
some ASCII art.
Yeah, that's what I was going to say. It looks like, yeah, there you go. You got a string. Welcome to the Among Them challenge.
Yep. There we go. Easiest thing to do is just get it running. Let's connect to it for starters. Yeah, let's just run it over here. Nuke my file system. That doesn't come out so great.
Oh, okay. Apparently the staff has a very useful piece of video for us regarding this challenge. Okay, that had not happened so far. So staff, if you want to come in, just roll the video. Wait, they're uploading it real quick. Okay, so in a few seconds.
Back at that. Should I quit working and let you run the video? Also, you know, I got this thing. I don't know if you can read that.
What is this?
What? Don't open until prompted on. Wait, April 32nd?
April 30th, 2021.
I was like, wow, we really did invent time travel here.
I don't know if that's gonna. You know how hard it was for me not to open that, or maybe I did, and this wasn't an anti-tamper bag.
Tim is saying you are not prompted yet.
I am not prompted yet. Okay. All right.
All right, so the video is ready. We're gonna roll the video real quick. Be right back.
Hi Colonel Khan, welcome. I'm Cyphertex. I hope you'll hang around to see Chris Eagle as he works on the Among Them challenge, which I created just for him. He'll have to not only reverse engineer to figure out how he needs to repair his spaceship, but survive a mysterious crewmate that might be out to sabotage him.
Oh, I love it.
Sick.
I absolutely love it.
Nice. Okay.
I was the imposter.
have you ever played Among Us, Chris?
I have not. My son loves it. So, well, all right then. So this is what we're seeing when we started up. What do we want to do next? I don't know. Let's see what happens. Okay, so it looks like things go away, right? If I can knock them off. Okay.
No, don't put away rifles. You need the rifles. What if you have to shoot something?
That's a good hint. That's a good idea. Let's see.
I absolutely love the reference here. So you can choose your task, and For those who never played Among Us, you're in a spaceship in the middle of the space with a bunch of people, with a bunch of other players, and one of those is a killer, is an imposter. And while you complete your tasks to actually save the spaceship, because it is going down since the imposter is meddling with it, while you do your tasks, you can be killed. So you have to choose in between a bunch of tasks to save your spaceship, and you have to choose very wisely, because if you're in the room with the imposter, that may be your last task.
Crewmates were all killed before I could finish my tasks. Okay.
Oh no. So I wonder if maybe the tasks have to be completed in a particular order, maybe?
Well, yeah, that's a good thing to know. There were, let's see, let's get that menu up again. Right, so there were 10 tasks, and we did see a loop of 10 things, right? And they did, I see that I have 10 different tasks this time, right? So they're randomly selecting from that list of, say, 34 tasks that they had, right, to fill their task list. All right. So I'm going to have to get some basic menuing done if I want to interact with this thing automatically.
One question I have is, these things are being randomly chosen. So if, a lot of times in reversing, at least in CTF challenges, it's like you have to patch something or, write a keygen or something like that. With random stuff, I generally tend to like mess with the seeding part so that, I get like a predictable value out of the random number generator. And then that narrows my space for, what I want to work on to fix things.
Yeah, that's a great suggestion. So all I know at this point is the randomness is seeded with time. So that's okay. If I try to hit their server, if I get an IP address eventually, I can work with that a little bit, right? So I can look at my local time, right, and I can look at the menu they give me. Right, and I can run forward and backward until I get that sequence of integers to know what their seed was, right, to choose that particular sequence of strings. Does that make sense?
Yep.
That'll get me a basic, like, do this thing. So the idea is I know where these strings are in memory, right? I know what their string array looks like, so I know what index they pulled fixed shower from. And so if we go back to these, where are they? So they're doing, let's get to it from over here. Right, so these are the tasks. Right, and so one of these is fixed shower right here, right? So one of their random numbers hit down here at whatever offset that happens to be. And I can try to get that same random number sequence, right? By just manipulating my time, my seed to my random. And again, if I can do the same one, then I know the random number seed that they were using, and I might be able to leverage that. So let's change this data type here. So they're saying 39. Is that going to be right? I don't know. I might need this, so I'm gonna pull this out of IDA. Right. So hang on a second. And so if you get your data typing right, I can do something like this. I'll just throw this in my Python script. Right, and so now I have a Python list of all the strings, okay, that I can search later on. Like I could search my list and I could get the index of fix shower right here, right, and know what random number they generated to get that particular index. May or may not prove useful, but it's ready to go if it turns out to be the case. So this is just printing a banner right here, right? And so now they are, what are they doing? Sterlen of that thing is less than 9. So what are they doing with that? What's this one going to do? They're going to print out our remaining task. Right, so that thing we found earlier with the structs, right? These are our tasks. That's the task name, among other things. Right, so they're loop for 10. What's this one doing?
I love the comment in the chat. Plot twist. Chris is using social engineering against us, and he is the real imposter.
Chris, you're the insider threat now. Congratulations.
That means I win, right? Something like that.
Right, yeah. Exactly.
No, you gotta kill all the crewmates before you win, and you cannot be ejected. For those who are not acquainted with Among Us, the crewmates have rounds of emergency meetings, and they can talk to each other. Yeah, and they can talk to each other to decide to throw someone into space. And that person can be a crewmate or can be the actual imposter. If it's the imposter, crewmates win. So social engineering is a lot.
Did you guys send me a pizza or something? I was wondering where my pizza is.
It might be there. It might be there.
Either my wife's making a lot of noise. Okay, hang on. There's banging at the front door.
Marina and I have headphones on, so there's probably like been 3 pizza people that have like come by and knocked on the door and rang the doorbell, and they're like, nobody's home.
Emergency meeting in the cafeteria, y'all.
Yes. So I wanted to kind of talk a little bit about what Chris is doing here. And when I would work in IDA, I would initially think of building out the structs and renaming or like labeling the variables and stuff. I would kind of think of that work as being like overhead, right? But once you get into you start digging into your analysis, you're really glad when you have those data structures built out or when you've got your variable names renamed, because then you end up having what almost looks like source code, and you've got like a way better understanding of the program. So Chris, I was just advocating for your approach of like building out the data structures and labeling the variables and everything as you were encountering them.
Oh man, I do it all the time. Yeah. Among other things, it cleans up the decompilation so much, right? These tools, IDA in particular, they do a great job of inferring your data types, but when you get a custom, structure type, right, they don't know it, right? They don't see the header files, right? So, IDA ships they've parsed out all of the standard library headers, and they give you tools, and you can parse any other headers you might come across. But for something like this with a data structure that the Hexrace folks had never seen before, that doesn't ship, as a known type to IDA, right? If you can build it out, right, you can see it starts to clean up, and they start to use a much better syntax instead of a lot of pointer math. So I can't advocate enough for that. I will tell you, it does slow me down in CTFs, right? Because it's such a part of my workflow, right? That I'm over here like making data types and making all the decompilations pretty, right? And so I won't say that I don't solve everything, and B, I'm not the fastest solver places, but my disassemblies look good.
Yeah, right. I would
to
open
look
that.
good than to be good, right, baby?
I'd open that IDB.
Okay, so what is that one? I still don't know what this thing is, right? I have to go back and see where they started assigning that. They read it in a lot of places.
So the way that Chris is doing this is looking at cross references or XREFs in IDA, and so you can see like where does a particular variable get assigned, or where does it get referenced, and that ends up being very valuable as well.
So they're just working their way through. This is actually test 0. Oh. Yeah, so they're cutting into the task name array. This is just printing the task, and I think that this is probably a Boolean array, an array of Booleans. It's telling them whether the task has been completed or not. Right? And if the task has not been completed, then they print it. That's all that's going on right here. At least that's what I'm going to tell myself, right?
And then it returns like a new line at the end, I think.
Well, so you see, I think what they're doing is, again, they've got this array of Booleans. This is just a wild guess at this point, and it's listing out the tasks you have yet to do, 0 through 9. And as you knock off a task, right? Well, it's an array of characters. It just collapses the array a little bit, right? And so as long as let's see, this is less than or equal to 9, it would have to get greater than 9. Maybe this is the array of completed tasks. Okay, and so once you've completed 10 tasks, then the string length of this grows to 10 because you've got all your integers, your characters 0 through 9 in this array, right? Once it grows beyond 10, then or to 10, then you fall out of this loop. Make sense?
Definitely.
What do I want to do next? I'm always I do a lot of variable naming too. And df equals 81. So let's do that as a character. Right. So they're doing some masking for whatever reason.
That's checking your quit. Like, are you
Sure.
quitting?
Yeah, it is. I wonder if that's uppercasing, right? A lowercase q.
Yeah, I think so.
So
that's cool. I've not seen it done that way before.
Which task now? What is this one? I don't remember being asked a second thing. Which task do you want to do next? 0. Back to it. So they scan. I always struggle with all this menuing stuff. So you can do Q. Oh, this is an scanf, right? So if it wasn't a Q, we'll fall into here, and they're going to scan the string that was just scanned, right, for an integer. So this will just be input, right? And we'll just make sure input is large enough. So input looks like an 88-byte array, right? So my scanf that's willing to take 19 characters doesn't seem to be problematic. So this will be our choice integer that they're going to scan. They scanned one thing. They come in here. The other thing IDA can do for you is clean up some of these variables. Like v9 is clearly redundant here. So we'll just make that the same as choice, right? And it looks like v10 might also be redundant right here, right? So we'll just make that choice. Oh, it didn't offer me choice. array for undo. Let's see. So yeah, it's not allowing me to map to that one. So let's see what we got. So this, I think, again, I haven't seen here's a write into this array down here, right? And so what they're doing is they're taking your integer choice and they're just moving it into the 0 to 9 ASCII range, right? And they're appending it onto the end of this array. So this is like an array of completed. Right? And we're going to call that, let's say, for now, we'll call it an array of 11, assuming they leave room for a null. Right? You see there is some additional space down there. Okay, so this just checks and sees it is our choice, again, plus, as an ASCII right here, is our choice, right, in the completed array, right? And if it is, that we get this message, or if our choice is out of range, if it's greater than 9, okay, then we get this message. There's some interest. Let's see. Choice is data typed as an unsigned int, right? And so
It's a
at
byte, right?
it is a byte. It is a byte, right? Uint 8 right here.
Yeah.
Right. So I'm going to assume that the comparison is correct. Like -1 might work, right? And might, this is something that I would keep in my mind. Can I do negative indexing?
Yeah,
Right.
my mind also went there. Like initially, I was like, "Oh, it's taking user input, and it's like it's expecting an integer. So can I give it, like 2 billion, or can I give it like something negative, or 4 billion, or what's the space?" Yep.
Yeah. So it looks like they've clamped choice down to just an integer or a char. Although here it's got to be an int, right? Because scanf doesn't know that you're only giving it a char. Right? So they expect address of int, and choice here. Yeah. I'll contemplate that one later. Okay, so what are we going to do? So we've made a valid choice, right? They go get our task. They take the address of our task structure, right? So Y7 has been, right? Or V7 here has been set to point into our task array based on our choice. And they're going to mem copy into V15. What is the size of V15? So that looks, and that's also a task, right? Size of V15. IDA has it as 33 bytes, but we can data type this as a task. Call that task. Okay. And that's just a task copy. I'm going to use up all my time just renaming things. So then they've got this function here. What's V16? Okay, V16 looks like a byte array, maybe, right? So that's a pointer being passed in here. The function doesn't know that yet. Chosen task plus 33 is the task after this one in the array, right? That's the size of task, like that. V11, integer, uninitialized, perhaps. Hello. 0, V12, got a lot of stuff going on here. Let's go take a look at this function, right? Invalid
Yeah.
digits, and then we're in our loop, right? So we got to be in all that. And ultimately, I'll drill into that function in a minute. So we completed our tasks. Then they're going to do a thing here, right? And whatever this is. Okay, this is just an array of dots, right? Run around for some number of time, right? Amount of time, sleeping for 1 second at a time. That's just a delay function, not a big deal. I set the debug environment variable, I can get around the alarm and the delay. They come back and do this. They are doing a check on the completed array, I'm pretty certain, in here. Okay. Okay, and so this is perhaps a size A2 right here. If not A2, what are they doing with A2? They don't check it initially. Otherwise, while V8 is not equal to the address, so I think this is just a length of the array. Makes sense. Okay. Some kind of, I'm going to call this a checksumming or decoding or decrypting. You see the XOR in here, and ultimately they're writing values into this dword5 array. And it looks like it maybe only happens the first time you come in this function, right? So if that first word in the array is 0, we drop in and we run through this loop 256 times. Okay, and so for each pass through the loop, they run this loop, okay, on V6, which decrements. So this is a loop that runs 8 times. Okay, and ultimately they take some result here, V5, which starts out as your counter and participates, right, in this XORing operation, okay, and ultimately gets XORed in here to flip the upper bits and gets saved in this, I don't know, array of values. And
Hey, Chris.
finally, yes.
Oh, sorry, keep going. Well, say the finally part.
So finally, then they're going to derive their result, right, by indexing into this an array, right, based off of our completed array right here, right? They haven't touched that array yet, right? And so they're going to they're going to loop through it, choosing the bytes out of our completed array, right? XORing them with the current result. That's got to be a valid index into the array. It will be because they're taking it as an unsigned int 8 in a 256 byte array. They XOR that again with the current result shifted right by 8, right? And then they return this result. Hey, Daddy, go ahead. Sorry.
Yeah, I was just saying, sometimes I give IPsec a hard time about this because IPsec is really good at recognizing certain bytes and characters in base 64 strings, but sometimes certain values like kind of just stick in my brain. And I saw that that V7, right? And I was like, EDB something, and then the 320. I'm like, it seems so familiar. I swear that I've seen this before. And so does that number or that hex value EDB 888 320, or sorry, EDB 88 320, does that stand out to you for any reason? Generally when I see this in code, I tend to ask why is this a value, right? Like the author put this value here specifically. And so is it something they did intentionally, or is it they just picked a random number? And I end up doing what you're doing, is searching, that value.
Yeah, precisely. So, constants like that often don't appear out of nowhere.
Yep.
Right, but are part of some algorithm. You see it a lot if you stumble across like MD5 or SHA-1 or something like that, the IVs.
Yep.
And so, yeah, Google's a great resource right there. Right, so take that constant, and then you're probably going to get some reference code, right, for whatever that algorithm is. Right. So here's a simple example. I don't know. This one's a CRC32. So maybe it's just ordinary CRC32. How is it calculated? Stack Overflow has all the answers, right? And there you see it turning up right there.
And we see the shifts and we see the XORs.
Yep. Loop of 256. Here's a loop of 8, right? And so very likely it's a straight up CRC32.
Dope.
Right. Actually, it's the CRC32 probably table generator, right? And in fact, that's what it says here. That's how the table is formed, right? So they only do it once. Once they have it, there's no reason to recompute it every time they come in.
And see, I love this because once you see this, frequently enough, you memorize it and it sticks, right? And you're just like, oh yeah, it's CRC32. But when you don't know this, you're like, how do I figure out what this is? I had a time where I was reversing something. There was like RC4. I didn't realize I was reversing RC4. And then somebody walked by and they looked at it and they're like, oh, that's RC4. And I was like, how do you know that? And they're like, I just know, right? And so when you can save time, my takeaway, like once I started reversing, my takeaway was the key to reversing was figuring out what to not look at.
Yeah.
And so in this case, is like, we don't need to necessarily understand like what's happening specifically inside this function. If we can look at it and be like, oh, it's CRC32, we can just say, yep, it's a checksum function, on to the next thing.
Yep, exactly. All great points. Yeah, RC4, I can almost write that one from memory.
Yes.
Yeah.
Awesome.
Yeah, you just see it a lot, and he's like, yep. I know exactly the kinds of things that guy was probably looking at when he said, oh, it's RC4. So then what they're doing, so again, if it's been computed, fine, we don't drop in here. And if we didn't provide a completed array, we don't get here. But then what they do is they iterate over all the bytes of the array, right, using that byte and the current result as an index into the CRC table. And that value pulled out of the CRC table gets XORed with the current result. And eventually we're going to drop out of here and return this result. And this result had better be this value, right? So there's our goal right there, right? Is we need to do the operations, right, in the right order, right? So really what operations are in here don't really matter, right? Because we're going to have 0 through 9. We need to get our completed string, right? It's going to be a string containing one instance each of the characters 0 through 9, right? Some permutation on that. And as we walk across that string and access the CRC32 table to pull out the values, ultimately the result of that function, right, needs to yield this value, right? This is, let's just call this a win value.
Our good boy.
Yeah, right. So I'm also, unfortunately, a stickler for spelling, and I'm a bad typer and a stickler for spelling, which means I type twice as much as I have to.
You're internally engaged in battle with yourself.
Yes. So, all right. So if we don't hit the win value, we're defeated. Otherwise, they're going to do all of this stuff. They're going to derive V17. They're going to do this thing. And then they're going to print this thing. Oh, you know what? I bet that's a flag. Right?
I bet you're right.
Okay. Right? Flag maybe. And so they do some, I don't know what they're going to do. In an ideal world, right, we could just go get the flag without going through the process.
Yeah, but as an ideal challenge, you would force the correct input to then, seed the decoding of the flag.
Yeah, of course.
It's not like you can just patch and get your good boy message and win.
Right. So you can see that how they're using the completed array, right? And they're plucking individual characters out of the array, right? And they're doing, some shifting on these, not by 25 and 17, which are almost multiples of 8, but not quite. To compose 4 integers, right? And so we got 3 and 0 and 2 and 1 and so on to compose 4 integers here, or an array of 4 integers. And then what are they going to do with that? They're going to run that through this function. And I don't want to go through this at all, right? Again, but here's some more magic numbers that might be meaningful. Right? And so it's better if I think it's just better if I try to win the CRC battle. Right? But either way, right? I mean, if I win the CRC battle, in theory, I know. So I could find potentially a CRC collision. Nah, I don't know. I'm not good at this stuff. So I'm going to come up with some roundabout way of solving it. This function looks a little too ugly for me.
Yeah, when I see functions like that, I'm like, this is above my pay grade.
So I'm a very much like a path of least resistance like approach to the binaries, and so like I'll drop into a function like I just dropped into this one and go, yeah, nope, not right now. And oh, look, it's a T algorithm.
Nice.
Okay, so it's the tiny encryption algorithm for those that don't know T. So it's probably like T decrypt. Let's call it T decrypt. Right, and so they very kindly perhaps encrypted the flag, and they are. I'm wondering if this is just because they never write to this variable right here, so it's going to be a 0. I don't know why they negate it. Right, negative of that. That's odd.
-0, as you do.
Yep. So I just wonder if that's like a direction flag, though. Like, I think T is symmetric, so this might be just a flag for encrypt decrypt. Maybe. I'm just throwing guesses out there, but I think that this is the key. Right. Again, derived from our input string, and so if I win the CRC battle, then maybe I win this. Although in the worst case, there's a CRC collision, and that's going to be bad. Or so what's my way forward? We didn't even look at this stuff up here. Go back to this function.
Yeah, to me, that particular subroutine, the 401 3D2, was like the meat that jumped out at me of like, this is the thing that I really want to take apart and get the full understanding of what's happening.
Yep. I mean, I have the mechanics of the outer part, right? We do some tasks. We build this string that's the sequence, I'm pretty sure, of tasks that we've done. And we can verify that pretty quickly, I hope. Let's see. What do we want to do next? Let's just I'll go back and forth. So I did 9. I'll do, oops, I can't do that one. I'll do 9.
Also, could we patch that function that has, that does the progress, right? Where it's like sleeping for 1 second between dots. Could we patch that and just put a 0 for the sleep?
Yeah, we sure could. I just set the debug environment variable though.
Oh, even better.
Right?
Yep.
So yeah, now I'm getting like lightning fast responses. So if we build a string up,
it's like, our time is valuable. Come on.
Yeah.
I don't have time to wait around on some function to show me some cool ...
Right. So now I've got it.
Talking about time, y'all.
I went too far.
You have around 25 minutes.
Oh, that's not good.
And like that, she's gone.
Okay, I'm going to hold off on the last one. So let's see.
Cyphertext says plenty of time. You got this, Chris. And now we're switching from static analysis to dynamic analysis.
Well, I just want to verify some hunches, right? So fortunately, it is not built as a pi binary, right? So I got some nice static addresses down here. So when we go into what I think is the completed array right here, I just want to validate one of my assertions here. Right, you can see that's exactly the order I was going toggling back and forth, low, high, low, high, low, high. Right, so that's exactly the order I've been going in with only 5 left to do. Right, so indeed, this is that's just a sequence of events, and so it's just a matter of, in fact, they don't even use the randomization there. It's just a matter of coming up with the right sequence of the 10 decimal digits, right? I think to get us what we need.
Yeah, I think you're right. That was kind of at least my suspicion at this point.
So I got to remind myself what V16 was. Looks like an array. And this is a task pointer on the second one. And it looks like, so we've got field 0, we've got some dereferenced bits of the name. It's almost like, I hate when I do that. It's almost like we got the whole task struct on the stack. Let's go see what has happened in the function. I haven't been in here yet. And that's a lot of arguments, right?
Right. Yeah.
Oh, delay. Yeah, it's nothing. So it's a nothing, right? All those arguments for nothing.
How I'm so confused because, like the parameters aren't getting referenced, are they?
Yeah. So right here, address of A7.
Okay.
Right. They're treating it, +1. So the tail end of this, right, is getting referenced. High byte of A10. Yeah, I feel like it's. Yeah, I don't know what's going on there.
I think ciphertext messing with you, messing with IDA.
Could be. Yeah, it almost looks like he's passing the argument by value instead of passing a pointer in or something like that, passing a copy of the task. Like the whole task structure on the stack. I don't know. Doesn't matter. The function's basically a NOP, right? This is all we get.
Yeah, right. It's literally output to standard out with a sleep in there. That's it.
So, oh man, now I need to. Unfortunately, right, a hash or a CRC collision is not going to do for me. So let's see. Let's think about what happens at the very end here. We'll assume, and I hope it's a correct assumption, that's a pretty standard CRC 32 table, right? And if I knew more Python and more CRC 32, maybe I'll go Google it. I can probably get access to the table, or I can just generate the table myself like this, right? So you take this and turn it into Python, and I'll have the table. Right through there. All those strings, getting all those strings out was pointless, I think. Right, so and don't laugh at my Python, please.
Never that. And ciphertext says that assume it to be straightforward.
Cool. Thank you. So what are we going to do? We're going to say I'm also kind of a stickler for formatting, unfortunately.
Does the editor have like the shift edit where it can you can highlight a whole block and then unindent it?
Oh yeah.
Nice.
Yeah. I don't want to do I right there. We'll do V6. Is that going to work for us? Because they don't use V6. Yeah, so that's just a counter.
I love watching this in action because it's like you are just magically doing Google Translate for C to Python. What is the original language? C. What's the resulting language? Python.
Yeah, what do I need? Yeah. So let's see. So we've got our constant there. We can make use of that. That's fine, I think. We don't need this one. Where'd V3 come from? I lost a variable.
A challenger appears.
Yeah.
Yeah, what is that V3? It's just
V3 is 0.
Yeah, it points to the first offset in the CRC 32 table, right?
So it starts out as 0, right? So because if we get through this if, right, it must have been 0, right? And it remains 0 for the duration.
Yep. Yeah,
so it's just 0. Yeah, so it's just 0. You're not buying that. I heard kind of a
Well, I was just I was wondering, is the table getting updated anywhere?
Yeah, the table gets updated. Here's where I append to the table, right? From V5. V5 comes from V7, and V7 only gets to set to 0 if V5 and 1 is not 0.
Right. And V3 had read from that only once, and so the
so
V3
that's on
is
odds.
It's its own separate copy, and that copy does not get updated. Yep. Okay.
Yeah. So you see, it's going to be odds, right?
Yep.
So V5 is just I. So this is I and 1 at this point.
Yep.
Right. At least in the first time through. So, I don't know. I'm just going to push the I believe button.
Yeah, let's go for it.
Okay, and we'll say we got it. I mean, I could like run it.
And I guess for full disclosure, every time that I'm encouraging you to run it or like just go for it, the Kernel Con site listed my superpower as fucking around and finding out. So
okay.
That is me using my superpower, apparently, is just telling you to go for it. See what happens.
Let's see. Yeah, I like that. Right. So let's just do this.
Amor, how are we doing on time?
Y'all got 20 minutes to solve this.
Oh, easy. Chris is just putting on the showmanship part. We're going to be at like 19:30, and Chris is going to be like, oh, by the way, it's this.
Yeah, okay. So let's go find the CRC32 table and see if we generated it right.
Yeah, I think the CRC32 stuff should be legit.
Now I just need to know that my algorithm is right.
Oh, right on. Did your internal translate from C to Python actually produce the correct output? Right.
And I don't know. If that's the table, I don't think I'm right.
You could also there's like Python modules, right, that do like the CRC stuff. You could just use that potentially.
I'm sure that I could. That's another Google. Let's see.
I absolutely love.
Apparently, is dropping some hints there.
I love that Python has the Python integration, right? Like I remember trying to write stuff writing stuff with the IDC, and then just Python. At least for me, like I mean, IDC was okay, but the Python integration for me was such a game changer. And to be honest, at the time, I think either Ruby was also like potentially a thing.
That was never a thing.
What? Oh my gosh. We're gonna have to
stop trying to make fetch happen, man.
Well, you know, now I'm all for Python.
Oh my God, that reference. Thank you. Someone who is educated around here.
But yeah, anyways, the Python integration, great. And then now we can just go look at Python and easily work in a very approachable language.
So IDA Ruby, basically, I'm pretty sure the timeline is that comes out basically the time that Metasploit changed over to Ruby.
Yep, exactly.
Because Spoon was, part in with the Metasploit guys, right?
Yep.
So, but he may have been the only person that knew how to use it. I'm not sure. I've lost my way.
Right. So we're just going to, instead of like worrying about our port of the CRC32 stuff, we're just going to use, or we're going to maybe try the native Python approach for CRC32.
Yeah. At first, I want to approach the solving. So let's see. Before I even dig into that, right? Let's figure out what happened. So we got a standard CRC32 table. So then what are they doing down here, right? We start out with a result of 0, right? They're going to XOR that with what is effectively a task number, right? The ASCII value for our task number. They're going to XOR that with result. Okay, now our task numbers are ASCII integers, so that's only going to modify the low byte of result. We know that, right? In any case, they're going to truncate, and they're going to use that as a lookup in here. Okay, so we know that the first one let's see. No, we don't know the first one. It's whatever your first task is. Oh, the first one is exactly the first task because result starts out as 0, right? So we know the first contribution to the result is CRC table sub task number, right, as an ASCII value, like sub 48 because it was task 0. I don't know if that's going to be helpful. They're going to XOR that with result shifted right by 8. So let's see. Again, in the first case, that's going to be a 0. What I really want is just a neat Python way to get access to the table. Because after they generate the table, unfortunately, right, they are not doing a CRC calculation, right? I don't think this is there. Maybe this is a CRC calculation. I don't know what the. Go look at that algorithm again.
I wonder, like, crypto is not one of my strong suits, and I wonder how many other reverse engineers kind of encounter crypto as this sort of like pitfall where it's like you end up digging into it, you know, so much. And in my experience, every time that I look at like crypto stuff, checksumming or, you know, encryption or decryption or whatever, I'm just like, I don't know, whatever the doc says, how do I just like not have to look into the crypto stuff?
See, that's the beauty of being part of a CTF team. Right? You just turn to your right and you lean on your crypto guy.
Yep.
And say,
or gal, or they,
or your person, your crypto person. Yes, that is absolutely right. And you just toss the problem over the fence to them, right?
Yep.
And they're like, absolutely. And it comes back faster than you can blink, because they're that good.
And this is a good reminder to everybody, right? In the CTF, it is literally like one person by themselves. But this is why we all have teams. And so it's okay. You don't have to be super amazing at everything. We have teams and people to help us.
Okay. So this is, in fact, exactly the CRC algorithm, right? So here where they look into they look at their table, they take the current CRC. In this case, though, the CRC starts at -1, right? And they XOR it with your byte, right, out of your buffer. They use that as the index into the table, which they XOR with the CRC shifted right by 8. Right? So and then they return the CRC, the inverse of the result.
Got it. Which looks very similar to that snippet of code that's at the end of that loop inside of the original binary.
It does, except again, not being a crypto person, they do start theirs at 0 rather than all Fs. Okay, but then they don't invert it at the end. So, you know, like a crypto person would know if they're equivalent, right, or not.
In this case, I wonder whether that's just like a compiler optimization, maybe, and maybe the code is exactly what we just saw on that previous screen on the web page. But maybe the compiler was like, oh, you know what? You can do the same thing if you just do like -1 or 0 instead, or like whatever, right? And so I wonder if it's effectively the same result.
Yeah. But I couldn't answer that question.
Well, we do have somebody that could answer that question, and they actually have a crypto-related term in their name. Their name is ciphertext.
Yeah, I'm happy to take that hint at this point.
Hello there. Yeah,
hey,
the hint earlier was, I'm not trying to be a troll. It is meant to be straightforward. You shouldn't have to recreate CRC 02. You can just call that. You should try that function that was on the page before.
Okay.
Save yourself some effort.
The Python
I was
function?
a little worried about that myself. Yeah. I actually wasn't sure myself. I had to try it too. I was like, is like CRC 02 that constant? Because I know some of those have similar, like there's slightly different implementations. So I wasn't totally sure, but yeah, you should be able to just give it a go.
So I think this is fair, or we can just call the Python version. I'm not sure whether I need some intermediate steps. I don't know. I mean, it's just a CR. Let's see. No, it's not just a CRC. Man. So I'm just going to throw this out there because we're getting short on time. I think I have a pretty solid understanding of what's going on, right?
I think you do too.
My crypto skills, how do I attack this CRC, right? To get something that's going to both generate a valid CRC, right, and then be a valid T key, right? I'm not sure I have a great shortcut way to doing that.
So you can ignore the T, which you kind of said earlier you might be able to do, and you were right. Your gut was that if you win the CRC, you're good. That's just there to get you the correct value. Once you got the correct value, it'll work for both. The T is just there to make it a not trivial to recreate and to pull out the flag. You've got to actually figure out the value first.
Yep. Okay, so let's think about this, right? So it all boils down to roughly this is the algorithm, right? If I have a completed string, something like this, right? Then this is what's happening, right?
So they're going. I would just use the Python CRC, but yeah, basically.
Yeah, no, I'm just trying to
get the value right. Yep.
That's a black box. I just want to think to myself, how are the characters being used in here? So they're running a CRC over this. Unfortunately, let's see, what is that? That's 10 digits. So that's what? 1 billion?
So I think the slightly different thing you're missing is that the whole function is the CRC, basically.
Yeah. Right. Build a table and run the CRC. Yep, I get that.
But the whole thing is just the CRC API equivalent, right? So you don't have to do anything weird to it. You can literally just pass in the same thing that you'd pass into the Python, and it should be the same.
Right. Okay. Yeah.
So it's basically figuring out what is the right input to get that CRC32 checksum.
Yeah, and I was worried because I was thinking, at first I just think it's 10 billion. That's too big. Is that's you're going to run into too many problems, but it's actually much smaller than that. And you even said this earlier. We were talking about what are valid possible inputs to this.
Okay. So that's the trick. Let's see. So you don't think it's 10 billion, huh?
It's not. Yeah.
I mean, you wrote it.
Yeah. So for context, at one point in an earlier version of the challenge, I had two smaller CRCs for the left half and the right half, just because I knew that could be brute forced. And then I was like, no, wait a minute. Actually, you can still brute force the whole thing in a very short period of time.
Yeah. So
you said earlier, you said a keyword earlier in particular that I'm going to say again because you already said it. So this is not a hint that you don't know. You just said permutations before.
Yep.
Right. That's the key thing.
Right.
Right.
Yep. Yeah. So it's whatever. It's 10 factorial. It's all right. Yeah. It's 9 factorial.
Yep.
9 factorial sounds about right.
One of the two. 9 or 10.
Yeah.
Something.
Hint.
I guess it's 10 factorial. I'm thinking of the characters and thinking if I multiply by 0, that's going to come out 0.
Yeah, if you got 10 possibilities and 10 slots.
I did the exact same thing.
Yeah. Okay, so that's not so bad, right? So now I just need to generate permutations on that string. Yep. Again, my Python fails me. I'm sure there's a Python thing that will do that, right?
Yeah, but is it iter tools? I want to say is maybe a module that can do it. I forget.
I think there's a couple different Python sort of native APIs you can do it with. You could do it even with just
5 minutes, yo.
All right.
All right. So you could do it with several different Python tools. I did a really lame way that turned out to work, which is I just used a shuffle library and gave it a list of the 10 characters and told it randomly shuffle it until you hit. It actually works. Yeah.
Nice.
That's a totally reasonable approach.
Me may end up doing more than 3
wait a minute.
times. You may end up making more, but
oh yeah, there it is. Iter tools.
Nice. See, dude. Question is, do I have this, right?
And
Yeah, I
y'all,
think I
pardon
used
me.
the random. Oh, go ahead.
I was just gonna say I'm gonna pop off for a quick
Oh, look
bathroom
at that.
break. I will be
In there.
back really quickly.
And so now we're gonna run over. Let's see. I got 5 minutes. You're killing me.
5 minutes and counting. No pressure.
Now my phone and editor permutations. So let's do that. And we got list of permutations. Let's see if we can do this for.
You got typo permutations.
Jordan, if you can take a look in the private chat, the staff is calling for you.
What am I getting back? Couples? Kill that.
I did have a little bit of fighting with
That was a bad idea.
formatting.
What's that?
I did have a little bit of fighting with like, oh, is this a byte array or a list or a string or like, the Python 3 does make that a little more annoying.
Man, it does not want to get me out of that loop, does it? Lovely. We'll just wait for all 3 million to generate.
3 minutes.
I'm not going to solve it in 3 minutes. You see, I got to wait for this to go. It won't let me break out of that.
Let's make a new shell.
Yes, like that.
Yeah, there you go.
Okay. So I lost my code. Let's see. So we're going to do. And that a couple? Can I do like
I don't know what permutations returned. I used the random shuffle API instead on my solver.
Then I got to deal with the CRC32 stuff. So
it's literally import binASCII and binASCII dot CRC32 passing the string.
Perfect. And let's see.
Jordan, just a quick pick there with the staff.
Can I?
I don't know if I can do this.
Here in StreamYard in the private chat.
Sorry, where do I paste?
Here on StreamYard, there is a tab called Private Chat, and this tab is talking to you.
Yes, I pasted it. I thought I pasted in what was asked for earlier, but I think we're just trying to get his solution working here.
I don't know if join is going to work on a tuple.
Just print P. Let's see what it does.
Yeah, I mean, I can print
the
P.
format
Sure.
is right on. Yeah.
Yeah, I just don't know if CRC32 will take it. I mean, I can always build strings by hand, I guess. Let's see.
Yeah, I don't remember if it does either or not. Yeah.
So is everything on fire? What did I miss?
Yeah,
well,
pretty
we
much.
might have a solve here, depending on this. Hey, that was fast. Interesting. Go run your binary.
Yeah.
Also, if anybody recognizes that number,
I missed it.
I didn't.
3-1 something.
3145.
What did you do? Let's see. Is it pi?
Yeah, without repeating digits.
The unique digits of pi, or the first 10 unique digits of pi, I guess.
Yeah, exactly.
So, where's my string? Damn it.
There was
Yeah. It's probably over here.
the modern browser.
341-159-26870. Right? So, that 3, 1, 4, 5, 9, 2, 6, 8, 7, 0. There you go.
Well
Surprise the
done.
imposter was
Well done.
Yes.
a nice challenge.
Yeah.
Good work.
That's
man.
dope.
That's good work.
Excellent work, y'all. Both on
Sort
the
of before
challenge.
1:30, right? I don't know if I went over Marina's time, but I made it before 1:30.
No,
You're like putting the screws
it's
to me
quite
there.
okay. You still have a few minutes left. I am just keeping you guys in a short leash because I know y'all like to take your time to finish. But yes, that was perfect. That was literally perfect.
All right. Whew.
That was
Heat's
so
off.
Well
cool.
done.
Pizza might almost still be warm.
And great challenge. That challenge was so cool. It was really fun to walk through,
It was.
seeing how like you
now
needed
it's
to get the actual
beer time.
right input. That was really cool.
Yeah, I enjoyed watching Chris's as Ariana as well too. It was a lot of fun seeing his, and I was a little worried. How do you get the difficulty right? But I think that was about the perfect timing for him to be able to really explain and go through it and mark it up and annotate it and show lots of people the process. So that was awesome.
Yeah, well done.
Yeah, if I was better at Python, it would have been smoother. But it
That's
was a
why,
nice challenge.
I wanted to hop on the
yeah.
end just to make sure the Python didn't be the stumbling block. Yeah,
You know me too well.
Well,
you got there.
And Jordan, you brought up a really good point, right? It's difficult to create these challenges where like you're trying to gauge the hacker's skill level and work within the constraints of the timing, right? So it's like like you're expecting like what can Chris solve within 90 minutes? Not like what can Chris solve within 90 minutes, but also solve within like 6 minutes, right? Because you don't know. Like people are really good. They might be like, oh, I've done something almost exactly like this before, or I know exactly what this is. It's Unix, and then all of a sudden it's like 5 minutes in, they've solved it, and you're like, what do we do with the other 85 minutes? Eat pizza, I guess, and have a drink.
there is a harder version of this. If you solved it really fast, it actually has a format string, only a leak built into it too. There's an error message that prints at the end that will leak you back bytes. And so if you solve the whole thing in like 30 minutes, we're like, okay, great. Now go solve it against the live server. Here's an IP address. And you had to first leak the binary back out from that. But that was like the harder mode. And we knew if we just did that from the beginning, there was a chance that it wouldn't get solved. So that was like in the pocket as all right, if you solve it too fast, you can go do this one as well. So if people want to try it at home, they can spin it up and try to use Pwn tools and actually leak the binary first and then solve it and just run it purely remotely.
Sick.
Thank you so much, everyone. This was just delightful. That was a delightful challenge. I had lots of fun. I am a huge gamer fan, so I just went nuts with with all the Among Us theme. And Chris, people in the chat were raving of how good it is to watch your process. All your thought process and your hacking skills are so refreshing. So thank you both so much for doing all of this amazing stuff here with us.
Two things. Number one, Colonel Con 25. You remember that's the discount code for no starch. And secondly, Chris has a package that said do not open until prompted. And Chris, you are now prompted to open bag number 1.
Wow. Was that predicated on me solving this thing or like?
Yeah, if you had to do return to sender if you didn't solve it.
Nice. Can I stop sharing my screen now? Is that?
No. I think this is part of it, right? It's going to be like.
But my screen. You don't need to see my desktop anymore, do you?
Yeah. We got that taken care of already.
I know. Okay. I got 1, 2, 3.
All right, so
4 and 0.
So number 1 is the one you're being instructed to open at this point.
Okay.
What's in the bag?
Let's see. I can go back to the video. Hang on a second. Can I drop back in the stream with you
Yeah,
guys?
yeah. If you just come back to the browser,
you already.
Cool. Yeah.
Yeah, you're
No,
already on
I wasn't seeing it because I didn't. Okay, what's coming out? All right. Hacker eye patch.
nice for when we get the ocular variant of COVID.
And so so am I supposed to put this? I don't understand. Is it just cool?
If you were too fast, you probably had to wear it while you were.
Yeah,
Had to
that
do
was,
one.
yeah.
Had to do it with one eye.
Nice,
Nice.
yeah.
Nice.
Inhibitor. I love it. Or hindrance.
So what? Do I have to send all the other ones back, or are they like?
Yeah, you were too good. Sorry, we didn't get to hinder you enough.
Oh, these were hindrances.
I think so. I don't know. Staff, is there like? Should we also do bags 0, 2, 3, and 4? What's up? Or are those like personal for
Tim
Chris?
is saying no. Tim
Okay.
is shaking his head and saying no.
All right, sounds
Is
good.
Tim asking for them back because he can't have them? I mean,
He's just evilly laughing at the backstage. I can see him. Y'all can't. He's taking advantage of that.
Well, whatever happens, make sure you spill it out publicly and make it a like Twitter infosec drama thread.
you bet. Hey, a couple of things. Marina 880, thanks so much for doing this. Jordan, thanks so much. Cyphertex, thanks so much for providing the challenge. And thanks, Colonel Khan, for inviting me, putting me in the hot seat. Fun and not fun simultaneously. And thanks to all the attendees for joining in, and hopefully useful and fun for you as well.
Yeah, definitely. Thanks for being in the hot seat. We got across the finish line, 6 minutes to spare. No, we had some fun hindrances in the packages, which you are welcome to keep, but
Right.
don't open them here because we don't want to spoil it for Joe.
Okay. So now I'm like all warmed up and ready to go for DEF CON quals that starts this afternoon.
Yes.
You got like what, 4 or 5 more hours left? You could get a little sleep.
Yeah.
Yeah, a little nap.
3 of them I'm going to spend with you though, right? I got to watch Joe, and then we're gonna see you again a little bit later, right?
That's right.
That's true. And eat your pizza.
And I got to eat my pizza. And I got to drink this beer.
Yeah.
Right? Yeah. So at least I had
So much to do, so little time. Oh my god.
Right.
a reward standing by for me.
Perfect. Thanks, Chris. Good job getting through it.
Thanks for all the help, the hints, and whatever. It was fun.
And big ups again to Cyphertex. That challenge was super dope.
Yeah, that was nice.
Yes, it was.
All right. I look forward to
seeing
checking in on Joe. Yeah, that's gonna be awesome.
Yep.
Thank you, Chris. Now we're going for our hardware hacking video. Is that it?
That is it. The hardware intro.
All right.